the maximum data rate of a channel. So in any channel, wherever the communication is taking place, so there is a limit, okay, that is the data rate or bit per second, how much it can send or allow. So 1924, an AT&T engineer, he is Harry Nyquist, he realized that even a channel which is regarded as perfect, that also has a finite transmission capacity, bit per second or sending rate. So Nyquist, he derived an equation and he derived it for the noiseless channel. So he derived an equation and expressing the maximum data rate bit per second for a finite bandwidth, especially in noiseless channel. In 1948, Claude Shannon, now he carried forward Nyquist work and extended it to the case where the channel has noise. For example, random noise, thermodynamic noise, thermal noise. Okay? Nyquist, noiseless channel, Shannon, noise channel or noised thermodynamic thermal channel. So Nyquist proved that if an arbitrary signal, any signal, through a low pass filter of bandwidth B, so the bandwidth is decided, this is the bandwidth, capital B. So this can be completely reconstructed by making only 2B exact samples per second. That is, one computer sending to another. We need, according to Nyquist, the signal can be reconstructed by making only and only, that is the exact 2B samples per second. So sampling the line faster than 2B, what does it mean? It is pointless. Why we are not talking about this? Because the higher frequency component that this kind of sampling could recover has already been filtered out. We have already used the filter. So the Nyquist theorem states that for signal of V discrete levels, what is this V? Now the Shannon doesn't have this V, discrete levels. So Nyquist theorem, I'll just tell you about the levels. So the maximum data rate will be 2 multiplied by B bandwidth multiplied by log base is 2 of V. V is the discrete levels. So this is the maximum data rate. I'll give you an example of that. So because Nyquist talked about noiseless channels, so let us consider we have a 3 kilohertz channel. Now these 3 kilohertz is the bandwidth, 3 kilohertz, and this channel cannot transmit binary. What is the maximum data rate? Binary means 0, 1. So we are talking about 2 levels. So this capital V is this level, this discrete level. Here for binary we are using 2. So this 3 kilohertz with 2 level, the maximum data rate is only 6 kbps or 6000 bps, bit per second. When it comes to noisy channel, we also call it as Shannon capacity. See, take any object, take anything, there will always be some random noise, thermal noise, because there will be molecules will be in motion and there will be some motion producing heat, very minute, but still it will be there. So there will be a thermal noise, thermodynamic noise. And this thermal noise is measured by the ratio of signal power, let us say S, to the noise power, capital N. That is, the noise is computed as signal to noise ratio, the signal power being sent and the noise present, noise power. So signal to noise, we also call it as SNR, signal to noise ratio, S by N. So this ratio can be very large. It can go up to a very high number. So in order for the computation to take place mathematically, we would like to make it in a range so that we can handle it. That is why this kind of ratio, in mostly other examples also you will see, this will be expressed on a log scale. So 10, then log, base is also 10, and then we have S by n. As I said, we are trying to mitigate the tremendous range. So the units of this log scale, we call it as decibels, dB. Deci means 10 here. And what is Bell? Bell is for the honor of Alexander Graham Bell, who first patented the telephone system. For example, the signal to noise ratio of 10 is 10 dB. The ratio of S by n, 100, is 20 dB. The ratio of this S by n, 1000, will be 30 dB. So this will be easier to compute also and to understand also. So this is the decibel. We are converting it into a decibel or log scale. So Shannon capacity or Shannon's major result is the maximum data rate or the maximum capacity for a noisy channel. Okay, Nyquist, noiseless channel. Claude Shannon, noisy channel. So he said, or he gave the expression, maximum data rate will be bandwidth multiplied by log, the base will be 2, 1 plus S by n. S by n is signal to noise ratio, bits per second. So B, you will always take in hertz. If it is in kilohertz, you have to convert it into hertz. And the signal to noise ratio, S by n. This is the maximum data rate.